Hey, I'm Hannah Weiss, the Education Manager at the Science Museum of Western Virginia, and this is your moment of STEM. So, if you have watched any of these videos, you may have noticed that I'm a little bit of a sci-fi enthusiast. I really love science fiction. And one of the common themes in sci-fi is that in order for us to get into space, to break through that final frontier, all we need is to invent that one faster-than-light engine, or the one that can use super little fuel to get between places. Just this one impossible drive that doesn't exist yet. Or, well, may not exist yet. Recently, there's been a lot of research into something that a lot of people are actually calling an impossible drive. It goes by a few names. So online, you may hear of it as the impossible drive or EM drive, sometimes even the Can-A or Q drive. All of these things are really one scientific concept, one idea, called a radio frequency resonance cavity drive. And these are things that may be propellantless thrust, meaning something that can generate thrust without using fuel. This is incredibly cool if it works. So there's a lot of debate about whether or not it works. And then, even if it does work, there are a lot of crazy theories out there about how it works. Now, all of those theories can really be broken down into about 3 categories. The first of those categories is that the results that we're seeing are experimental error. Now, experimental error is something that really any good scientific paper will talk about. These are things where the results are weird based on something that wasn't accounted for in the experiment. So saying that this is experimental error means that even though we're seeing some of these experiments generating thrust, it may not really be the result of the drive. The second big category that describes kind of where all this thrust is coming from is that, well, maybe we're not accounting for some fuel or some exhaust in the equation, meaning that it's not propellantless. But the third category is really cool, and that's the one that actually might be propellantless thrust. This category of theories says that the thrust that we're seeing is the result of some change in the electromagnetic or vacuum fields. Now, this is incredibly cool, not just because it's propellantless thrust, but because if it works this way, it means that our understanding of one of the core concepts in physics, conservation of momentum, is flawed. So conservation of momentum is a concept that a lot of people are familiar with because it's one of Newton's laws. So it's a law that says for every action, there is an equal and opposite reaction. That's momentum. So conservation of momentum is just that. So if this works this way, it means that our understanding of this core concept, this basic idea, is totally wrong, which might mean that there's a whole new type of physics to explore. Now, even though that is incredibly cool, it's not what I find the coolest about these drives. No, what I think is the coolest is that in some of the research, we're actually talking about Warpfield technology. That is total science fiction. Star Trek tech right there. Actually, the word is from Star Trek. We had the idea and words for Warpfield tech before we actually had the theoretical backing. Now, warp fields are not always talked about when talking about EM drives. You actually see them talked about a lot more when talking about another theoretical drive called an Alcubierre drive. However, just the fact that we're talking about them is so incredibly cool. I'm Hannah Weiss from the Science Museum of Western Virginia, and that final frontier is a lot closer today than it was yesterday.